speaker is a medical doctor and a health informatics professional, with over 20 years of working experience in the field of healthcare IT. He was the CIO of the Medical City Group, CIO of Healthway Medical Clinics, and CTO of Metro Pacific Health Tech. In this session, he will share his experiences and lessons learned about adopting microservices architecture in the healthcare domain. Everyone, please all welcome the CEO and founder of Med Projects, Dr. Michael Nguyen.
Good afternoon, everyone. I'll just share my screen. Okay, so this afternoon I'm going to avoid talking very technical. What I want to do is just want to share the experiences that we had now, working on microservices architecture in healthcare. So I've been doing this work for over 20 years, mostly in hospitals. So almost all of the major hospitals, I work on several projects, and I want to share yung mga learnings namin. So in the hospital setting, you actually have several systems inside. Sometimes those who are not familiar with the healthcare setting, they just think that there are machines, there are diagnostic tests, okay? But to operate the hospital, you need a lot of systems. The core system is actually the hospital information system. This helps manage the patient registration, billing, ordering. So that's the core transactional system. Other systems within the hospital are the laboratory information system, which gives out the complete blood count, urinalysis, fecalysis, all of those stuff. Radiology information system, which handles the imaging and the readings, and the EMR. Okay, but there are also other systems inside the hospital. So the healthcare industry is actually, in a way, stuck with legacy systems um, because of old systems that worked before in the early 90s and 2000. It worked for a single hospital. If you look at this is a screenshot of existing HIS. It works for a small hospital, but if you look at it, all the different domains, when you work on a patient, when you work on items, inventories, when you do bed management, monitoring HMOs, ICD-10, even the different transactions for patients are here. And then if you see, you have dietary, and then you have examination, ancillary, cash receipts, patient refunds. So can you just imagine the different domains that go inside one system? Obviously, this is a monolithic system. So our topic is moving towards microservices. Another legacy system is this one. I'm showing you systems that are in probably around 800 hospitals in the country. So when you go inside the hospital, you probably see these systems. So this is also another system that's a legacy one. If you see, you'll have clinical aspects here, but the financials also there. This is how they input the patient information, but you also see some financial information here. Okay? And everything is consolidated into one monolithic architecture uh, where reports are also done. Okay, so um, you do census, you do billing, you do field health, you do monthly reports, you do accounting reports, all in one system. Okay, so can you imagine the kind of challenges and problems that we have? So the typical problems and challenges inside the current systems are downtimes and system slowness. The biggest system slowness happens at end of the month when the different departments try to work on their reports, month-end reports. So everything will slow down. Even at even when accounting is the one data crunching, the admitting department, the discharge in the billing department will slow down. There is limited scalability, limited flexibility, lack of modularity. As you saw earlier, everything was inside one system, and it's hard to innovate. So in many ways, the systems that we have in the Philippines has been left 10 years. So we are 10 years behind what is available outside. And of course, there's also vendor lock-in. The emerging trends in healthcare, which also impacted because of the pandemic, is there is an increased need for interoperability and data exchange. Right now, you don't want your records to be kept in just one institution. If you need to move to another hospital, another clinic, it would be ideal to have your records also available from that one, right? So even in chains of clinics, let's say if you go to the medical city mall-based clinics, sometimes they don't have the when you go to one clinic and you go to another, they don't have the same records. There's also patient-centered care, which is emerging right now, which means that patients want more control of their data. So you want a way to access all your lab results, whether it comes from St. Luke's, Makati Med, Medical City, it won't matter. You want access to all of those, right? And there is also a trend for normalizing remote and telehealth services. We also need to consider cybersecurity. It's pretty hot right now, especially with the PhilHealth um, incident. And then we also have evolving business models, which means that there are healthcare scenarios that allow for subscription, HMOs, right? So if you just see how the patient data is impacted by the evolving business models, you'll see that legacy systems can be problematic. And also, we are looking at the possibility of healthcare ecosystem integration. This is where, for example, chains of hospitals talk to each other. The hospitals talk to PhilHealth. The hospitals talk to DOH. So we are looking at integration of a healthcare ecosystem. Even DOH wants that to happen. When I do work with hospitals, I try to come up with a canvas to look at the different domains that needs to be tackled when you create a 3 to 5 year roadmap. So when I started looking at how to improve hospital IT systems, it was very natural to look at the different domains inside the hospital. If you see, um, there are almost I identified 10 domains when I tried to plan for IT systems, but you can actually come up with a translation towards domain-driven design. That's why I was attracted to domain-driven design when I saw that there are a lot of domains inside healthcare. So just a quick run through of DDD. So DDD is a software development approach that emphasizes modeling a complex business domain as the core of the software system. Okay, so it involves collaboration between domain experts and software developers. When we were building our own systems, it was good that I was a domain expert and I was also a technical person. So it was easy to build and come up with plans and designs. Okay, the key concepts of domain-driven design. I will not. This is not a technical lecture. Just key concepts that would matter to the practical implementation was core domain, bounded context, and ubiquitous language. So I mentioned earlier the different domains inside healthcare. So we already identified several ones. Bounded context is where there are boundaries within a specific subset of the domains. A good sample would be between patient and orders, patient and inventory, patient and supplies, right? So those are bounded contexts. So, but within the bounded context, there are points where they meet up. This is an image from the internet where you actually meet up, whether it's a patient identifier, an order identifier. So that's how bounded contexts talk to each other. The third one is ubiquitous language. This is a shared and consistent language between developers and domain experts. What's good about healthcare is we already have an ubiquitous language. In many ways, we're already trained in the healthcare industry side to work with our own vocabulary. So if you come from the clinical side, you already know what needs to happen is for the IT side to become familiar with the different vocabularies that are available in healthcare. So one common and very important vocabulary is the ICD-10. The ICD-10 is the one that hospitals submit to PhilHealth, and that's where PhilHealth manages the claims and everything and processes. Okay, so if um, PhilHealth stored all our data, then all the diagnosis in PhilHealth will be in ICD-10 codes. Okay, we also have LOINC codes. We call it LOINC. This is where the formal names of the different lab results. And we also have HL7. HL7 is a standards body which also identifies the different fields that would matter when you try to exchange data, not design software, okay? When you try to exchange data, basically when I try to send you a patient profile, these are the fields that need to be sent out. This becomes an inspiration for designing software. So as you can see in healthcare, we already have domains, bounded context, ubiquitous language is pretty um, straightforward. When you look at the hospital information system, you will actually see all these three things, right? These are the most common modules when you work inside the hospital. This also reflects the business. So you have patient registration, inpatient admissions, outpatient, emergency. These are the different departments that register patients. So there is an outpatient department. They also work with patient data. There's also the ER, the inpatient, okay? And then there are other services that do not register patient, but work with patient data. There's a nursing services, orders, dietary. Then you also have laboratory, which gives out different data like CBC, urinalysis, and all the operational departments of the hospital: central supply, warehouse, inventory, purchasing, requisition, even the idea of buying bond paper, ball pen, okay, syringes, those becomes part of purchasing and requisition. Okay, linen, okay, and then you have accounting, and then of course reports. So once you have a good idea of the DDD inside healthcare, we go towards microservices. One of the things that attracted me to MSA was that, okay, it might be possible to build something better with what's applicable for healthcare. Okay, so microservices architecture is an architectural style um, that structures an application as a collection of small, independently deployable services. Okay, so the difference is when we look at it, the monolithic is this one on the left. Microservices allows for small applications that talk to each other. Okay. One thing that also attracted me to MSA was that you can have one team working on one microservice. This allows ownership and rapid development. Okay. So another team working on just one service and another team on one service. I'm sharing images from the internet, but later I'll show what we did. Okay, so this is another benefit of microservices is that when you have a web application, you can actually use the same microservices to build a mobile app or a different API gateway. Okay, if you see that the microservices also talk to their own databases. Okay, so let's go through our journey. We started using just one database, and then everything is in one application, right? So that's how we actually initially designed our software. Then we did initial attempts. So we tried to see which domain actually inside the database would work well as a microservice. So one of the things that we took out was actually the patient's database. So we took out all the patient demographics, last name, first name. We put it inside a different microservice. We put it inside a different database. Okay, it's not in the same database, not in the same database, just separate tables. No, we actually put it in a different database. put in an API and then built a front end for it. So another one that we took out is what we call value sets. These are actually reference or in or list of values. Let's say gender, uh, barangay, cities, HMOs. Okay, so we call them value sets. So we took them out because these are just we just refer to them. We don't add we add value sets at the back end, but we try to check them using the API. Okay, so I'm going to show you the system that we have. So this is uh, the health engine. If you can see, there are different modules. A lot of these modules share several microservices. Okay, so this is the patient registration module. If you see that, you can actually create a register patient in different modules. That's why it was good that we actually isolated it as a microservice. So we have an admission module that allows for patient registration. We also can see that when we did, if you look at the different domains inside the hospital, so you'll have patient management, but within the patient um, admission module, we are seeing some other possible areas for to become microservices. One of the things that we're looking at is to convert the bed management as a microservice, because if you just need the patient identity, but then what you need to look at when you need to manage beds is it occupied, available? Is it for cleaning? Is it for renovation? So in a sense, we are looking at maybe this might be a good candidate for a microservice instead of being embedded inside the whole application. Okay, that's for the admission. So we also have centralized outpatient. So this is where if you go to a hospital and you have a long line of people who want to do labs, no, they are not going to be admitted. They also do patient registration. So you can imagine that this also goes and uses the patient microservices. The emergency department also uses it. Okay, and then once the patient database is already available, then you'll have a patient profile. So the a lot of the information here might actually be coming from a separate microservice. Even just looking at one page, we have several possible microservices at work. So this one, the patient profile will come from the patient, we call it the master patient index microservices, but other tabs here might actually be stored in different microservices and databases. One of the things that we are looking at is to create a separate microservice for the medical history. So what happens with the medical history is if you go to a doctor and they try to write notes, you actually try to repeat all the same questions, right? So, what are you allergic? What's your current medications? Everything. But then it gets saved inside the document, not saved with a central repository, so that when another doctor looks at it, when you go to visit it another time, there is a central location for all of this medical history, whether you were operated 3 years ago. Okay, so we don't want them embedded in the clinical document. That's why it's important that can we actually do this as a microservice. So that's the plan. If you look at the different functionalities, even if you have the patient demographics, the patient MPI, you also need to work with the results, right? So we already tried to isolate the different results. This is already a separate microservice in the application. Okay. We even have inventory. Okay, so these are the samples. The current one that we have, but it's still evolving. Okay, the current one that we have is actually this one. So we have the MPI, the Master Patient Index, separated. We actually have a managed database instance. Okay, we are working in the cloud, so we have a managed database instance, but there are several databases inside. So the MPI has its own database. The CAS, the Central Authentication System, already also has its own database. This is where we try to identify roles, permissions, even identifying form field permissions. So this is where we try to identify this one. The orders are here, but it also contains the billing because what we just need for orders is just the patient ID, but then we look at all the different transactions and it matches with the inventory. If you order a syringe, if you order a medication, that becomes reflected in the inventory. That's why the inventory is also inside the orders. The EMR is where I mentioned earlier that there's clinical documentation that happens. So all the documents are stored here in the EMR database. And then others, there are other modules, they are all in different tables inside one database. So, but even if this is the back end, we look at several back end. The front end is different. It does not reflect the back end. So we have several modules that are reflected of which user. So the admitting department will use the admissions module. Pharmacy will use the pharmacy. Okay. Um, so right now, what we have is these are the several data dictionaries that we try to maintain for the different databases. So we have ARMS. This is for the Ancillary Results Management System. This has its own microservice. This is basically the form that allows for results data entry. So when we have hospitals who do not have a laboratory information system, they want to type in the results, let's say complete blood count, we have a separate microservice for that. We have a separate service for doctors, especially when you try to manage a lot of doctors. The EMR is here. This is clinical documents, MPI. We have a separate microservice for medical records management system. So this one is for scanned documents. Okay. If you look at the different microservices, we actually have several domains inside, right? So even subdomains or bounded context. So this is for the MPI, the patient. So the patients are here, but the names of the patients are actually separate because we allow for multiple patient names. Sometimes it's whether you're a baby, you have a baby name, then you actually get an adult name, or sometimes you need an alias, or sometimes you need to merge, right? So we look at all of those, and these are the different value sets inside. Okay, this is for the orders. Even with the orders, if you see here, we just need the patient ID, okay, and then everything is about the order. Okay? So one of the benefits of the microservice architecture is that it became almost like Lego blocks. So when we needed a different scenario, we actually were able to build several a solution using existing microservices, but building new ones that were not available. So it allowed us rapid development. Okay, so there was a scenario that required, so our base application was actually built for a hospital, but then we needed a scenario that was just for clinics. So we took out some of the microservices and then we built other ones that were not available. Okay, so there was scalability. When we needed to work on inventory, we were able to just look at the hardware and see if we could actually maximize each microservice. Okay. Um, Maintenance advantages. So sometimes we could deploy an API or microservice on its own. We don't need to work on others. We don't need to worry about others. Okay. So the challenge was actually a learning curve. So a lot of the new team members took a while to get used to the idea that if you need to work on orders, you just work on this order microservice. If you work on additional information fields, then you need to work on a different microservice. It took them a while. It was a bit complex for some who were not used to it, but then after a while, it became easier, especially if they get to be part of one microservices team. Okay. Another one is the complexity of infrastructure. Sometimes you need to deploy several instances, VMs, for the microservices. You need to plan this out. It's not problematic, but it can be challenging at the start. And another problem that we have is data analytics. So I showed earlier different databases. if I need to cross-check across databases, that can be a problem with data analytics. So I'll share with you the current project that we have. This is Quezon City. This is not a hospital. We actually implemented our software in all the health centers of Quezon City. So if you are a Quezon City resident and if you go to a local health center, an LGU health center, our system will be used there. So remember I mentioned that we started out a hospital IT system, um, but we needed to work on this. This one is not a hospital. This is a, a network of clinics, right? So we took out some of the modules, we built additional microservices. But what's good is that we actually launched within 3 months of kickoff, because after requirements gathering, we saw that we already have some workable modules. As I mentioned, it was like Lego blocks. So we were able to implement around 60% of the requirements because of the microservices. There were changes in the uh, patient profile because we needed to add additional fields. So this is where changing just the microservice for the patient mattered. So if you see here, I'll move to another page. We needed to work with Quezon City to work with their QC ID. So this is not available this was not an available default field in any of our systems. We had to add this, but it didn't impact the microservice. We just added additional fields. We also work with them on diagnostic results. So the health centers right now can actually work on lab results. So if the health center has a small laboratory, it's pretty basic. They have just CBC, urinalysis, and fecalysis, and I think blood sugar. They could actually type in their results and it gets sent. So if you see, this is the clinical documentation that I was mentioning about as a separate microservice. All of these documents, all of these notes are actually stored in a different microservice, in a different database inside the database instance. Okay, so right now we are even looking at dissecting, disassembling the clinical documentation. Because, for example, the vital signs is embedded in the clinical documents per episode, but it could also be done prior to a visit while the patient is waiting. Okay, so when you need to track all of those, you need to look at the different documents. Okay, so this is the document, the visit note for last week. This is the visit note for 2 days ago. This is the visit note, and all of those will have vital signs. So we're seeing that if we want to monitor vital signs, especially for blood pressure, we might need to create a microservice for it. Okay, so that's how we're thinking. It's not yet a decision, but I'm just trying to share how we are looking at the different problems that we encounter in healthcare and trying to come up with a better solution. Okay, another area that also poses problems in terms of the trends that we are looking at is e-prescription. So e-prescription is actually embedded inside a note. Okay, let me see here. Okay, so for this one, so this one is a note inside a visit note, an e-prescription. Okay, but then you also need to send this to a pharmacy. Okay, the way that we do it is we actually try to create a PDF for it, and then we come up with a printout that can be sent to a pharmacy. However, electronically, it's also stored inside the document. Okay, but what happens if we need to create uh, a separate page, a separate document that allows for the different medications that were prescribed to the patient? Okay, so, but we also need to embed it in other documents. So that's also one of the things that we're looking at. What if we also need to send to, let's say, PhilHealth? Okay, so those are the things that we are trying to decompose. Okay, so we are not there yet. I'm just sharing the different problems or scenarios that we are encountering. And this was one of the things that we built, and this is a separate microservice because this was a requirement for LGUs only. From our experience, we were not involved with the public sector before this one. So we didn't have this module. We were working with private hospitals. So this one was actually built as a microservice so that it gathers the data from the different databases and then consolidates it for the report for DOH. The output of this one is a bit complicated. So our first step is to output it as an Excel. But then later on, we will plan to create a separate data warehouse that would that would extract from the different databases and then send it to DOH. But this is also a challenge that we have because of the microservices. I'm sharing that it's not a perfect solution because of the microservices that we have separate databases. This kind of report can really be challenging. Okay, so an update on our situation. This is as of yesterday. Our system is doing well. It's being used in QC. We already have 120 plus registered patients in the database with the visits of 150 plus, which means that several patients already visited multiple times, and they also did consults several times because you could do multiple consults in one visit. You go for a dental consult and you go for general checkup, okay, in one visit. Okay, so we are already live in 91 uh, sites in Quezon City. So last two slides. Last two slides. What's next? Okay, I just want to share that we are not yet done. I'm sharing how we actually approach the different domains, the different requirements, the different needs. Healthcare is complex, but it's doable. So we are still building our microservices. We might need to look at which ones we need to bring in to consolidate, which ones we need to separate as a different microservice. We are also trying to build a data analytics framework. Right now, the ETL process is a bit uh, crude, raw, straightforward. We want to build it in such a way that it's already a good framework that allows for the ETL process to move properly, allows for real time if possible, and then we need to create a better data warehouse. And of course, we're hoping to get the next city to work on this one. Um, Last slide, the opportunities in healthcare software. I want to work with everyone on this. I was happy to be invited for this because I want to make a pitch to software companies. If you are interested in making a difference, okay, there are only less than 10 software companies focusing on healthcare, especially on enterprise healthcare. I'm sure there are smaller companies working on clinic management systems. Okay, but when it comes to enterprise software for hospitals, there's only less than 10. And we have 1,800 hospitals in the Philippines, and even our system right now is just working in one city. We have 149 cities, okay, and there are thousands and thousands of them. What's important to know is that the Philippine healthcare needs better software. So um, that's it. That's my talk. If there are questions, oh, there are actually questions. Sorry, this is my.
Okay, thank you so much, Dr. Mike, for that wonderful presentation. Why don't we show our appreciation to Dr. Mike's presentation by clicking our emojis? Oh, I see a lot of emojis. Okay, thank you guys. So moving on to our first question. This question is from Jonathan. What strategies and best practices can be employed to effectively handle authentication for multiple services within a microservices architecture, ensuring secure and streamlined access control across the system?
Okay, thank you for this question. Right now, we are working with JWTs. Okay, so the CAS, the CAS, we call it CAS, authentication system, acts the like Google or OAuth basically. So it handles JWTs, but that's also one of the things that we want to reconsider right now, because if you build it on your own, you actually need to basically in a way adapt or copy what's already available outside. So we are looking at replacing it or improving it, because right now we also have a need to work with um, probably the other identification services like Google, Facebook, all of those, or GitHub, and we also need to implement MFA, so multi-factor authentication. So, but right now, what we're using is JWTs across the different microservices, and then but we're looking at how to improve on this one.
Okay, I hope it answered your question, Sir Jonathan. So for the next question, it's from Janelle. Is microservices architecture is like a component-based structure?
Um, I'm not sure about the component-based structure, but what's important is you need to look at a microservice as an independent, uh, small application that just needs to work with others through API. Okay, so sometimes we have a microservice, for example, our value sets microservice. It's a bit old because we don't really need to improve it. The value set microservice is like a list of values. So, for example, the list of barangay, the list of uh, gender, okay, the or HMOs, right? So, the we just need to update the database, but the API itself, the software itself, is already built. So we can actually just take it out. We took it out from our hospital information and put it in Quezon City, and it's already ready. Okay, so that's the way to look at it is like a very small software. That's why I call it a Lego block. It's almost self-maintaining, but you need to work on the API, others, authentication, of course, as earlier mentioned. But then, as a function, it could actually be. You don't need to improve on it in some sense.
Great. So another question from Joe. How does data sharing between services impact latency, and what strategies can be employed to mitigate any potential latency issues?
Okay. So this is actually a very good question, and one of the things that we are trying to watch out for, because we are aware that there might be latency, especially in the cloud, but we have not yet encountered it. So we are, in a sense, just heightened awareness. But the way that we built it right now is we actually have three uh, VMs. Okay, so the back end, even if they actually different microservices, are actually within the same VM. So we have the capability to take it out, a microservice outside of its own, and put it inside its own VM. But right now we don't have the need for it. So all the back end APIs are actually in one VM. The database in a separate VM within the same virtual private network in that cloud. So all of them are talking to each other within their own internal IPs, not external ones. So that's how we built it. But we are
Okay.
aware that it's possible that latency can happen, and we're trying to see if, what we could do to improve on that one if that happens.
Okay, thank you for that. And another question from JC Makam. What is the main technical challenge that organizations encounter when transitioning to a microservices architecture, and how can this be effectively addressed?
Okay, so it's pretty hard to get out of monolith. There is nothing wrong with a monolithic architecture if you just want to work on a smaller business case. Okay, but as mentioned earlier about healthcare, healthcare is really uh, growing, right? It's already working with different environments. So the biggest technical challenge is getting out. But when you try to transition, as mentioned earlier, we identified several areas that is easiest to take out. So to create a microservice. So we took out patients, the patient database. Basically, you call that microservice to get all the patient names, and that's it. And then we took out the value sets. Okay, so the list of values, because you just need to refer if you want to do a UI of all the drop down, then that's the API that is called. All others were stayed inside the same database. and then we tried to plan out slowly others. Okay, so you don't need to do everything all at once. The way that we built our this is actually, I think, our fourth year or fifth year of the software. So we started with a semi monolith because we already a web. So we have back end and a front end separate, but all the back end had the same database, right? And then we slowly the isolated the different ones, the different domains.
Thank you for that, Dr. Mike. And also another question from Maki. What steps and compliance measures are we taking regarding the privacy of patient data on these distributed systems and microservices?
Okay, okay. So we have several ones. If you see that the good thing about microservices is they are actually stored in different databases. So the clinical data, the diagnosis and everything notes are actually separate from the patient database. So there are two databases, right? If you want to go through a database route of doing it, you need to basically breach two databases. But if you just want all the patient name, everything, addresses, then you just need the MPI. But if you want the diagnosis, the visit notes, that's in a separate database. So that's one area. Okay. But then on the front end side, we have what is called a break the glass feature. That's pretty standard in healthcare in EMRs. The break the glass feature is when you try to access the patient that is not your patient, you're asked explicitly to connect and um, ask for automatic permission by putting in your role, your the time, and again your password. So that's a break the glass feature. What happens is I'm doing a search. Please give me the Mike Muin, okay, and then say, okay, this patient is not your patient right now. So please identify your relationship. I am a doctor and I'm a referred doctor. So basically, the attending has access to the patient. I'm referring it to the doctor, and the doctor will type in, I am allowed to access this patient because I am a referred doctor, and give me access for the full length of the admission. We could also state whether you just need 4 hours, you just need 1 day. So that's part of the break the glass process. That's part of the EMR on the front end side, and then it
Great.
expires. It expires. So
Oh,
once it expires, and once the patient is discharged, all the doctors are actually taken off when the patient is discharged. So no doctor can access the records of an outpatient, even if he wants to, unless he actually breaks the glass.
great, Dr. Mike. So another question from Jerome. How do you deal with distributed transactions in microservices?
Okay, that's a pretty good question. I don't have the best answer for it. Right now, that's why we have orders, billing, and inventory still in one system. Um, the uh, orders just tracks which ones were ordered to the patient. For example, we order a CBC and that has a charge. The charge needs to go to billing. We were trying to plan to separate the two because billing has its own quirks in a sense with consolidation, posting in the SAP or financial system ERP, all of those. And then we also need to work with inventory. But it's really getting challenging because when you order CBC, that's okay, there's no inventory. But when you do order medicines, then you need to work with the inventory. Is it still available? Stock check. And then once it is dispensed, you then send it to billing. And the billing says, okay, I need to charge for that. So all of those are still a challenge. And in a way, that area is still a monolith for us. But we are trying to look at ways to, I don't know, improve on it.
Thank you, Dr. Mike. So we also have another question from Kevin. How do you deal health related scenarios where data is from the lower class? Do we have a roadmap in integrating with government?
Ah, yes. Okay. So this is a policy question. And yes, that's why Quezon City worked on this one because we already have the universal healthcare law, which requires primary healthcare centers, okay, all cities. Okay, I'm saying all cities are required to send information up to PhilHealth and the referrals to what we call apex hospitals. So you need to first, for example, you go to a health center, you need to be referred to uh, a hospital. Then this health center needs to send data to that hospital. That's already required under the universal healthcare law. But the implementation of it is still taking some time. It might come in probably 2025, 2026. In a way, Quezon City was a bit advanced by moving with that because we will be looking at the possibility of sending out the referrals. But that's already a law with universal healthcare law, and every city is required to comply with that in the next few years.
Thank you, Dr. Mike. And another question from Andrew. When do you use message queues, CAS or pub slash sub model to communicate or share data across different microservices? And when do you use simple API calls to communicate to other microservices?
Okay, so right now we don't have, we only use message queues for real time, not real time requirements. For example, you have orders that needs to go to a lab. The patient won't be in the lab anyway when you do the order. So we have an integration engine that handles message queuing for that one. But all else, it's as direct API calls. But we are exploring um, different uh, technology, especially Kafka. We are exploring. We are not yet experts. We are seeing, oh, there might be potential here, and just seeing how it might work for us. So that's the area that's another area for improvement for us. Right now, it's pretty straightforward. Within the same VM, they talk to each other through APIs.
Great. So another question we have, Jim. In the PH context, is it accurate to say that strict regulations makes it difficult for IT service providers or startups from gaining traction in the healthcare industry, making it challenging for them to partner up with businesses in the industry?
Um, there are strict regulations, but the strictest that means that it's really apparent, and that even businesses will be hesitant. Okay, is data privacy. Okay, so that's the most because uh, it's a pretty widely required, right? So you don't need to be healthcare for the data privacy uh, to work on your business. But then all other requirements, they are a bit, they're not loose, but they are a bit open for innovation. So there is nothing that would stop you from creating electronic documents of a visit, uh, an e-prescription. Okay? So there are some that would require retention of some paper in some in hospitals. So there are data retention policies. But in terms of innovation, you can actually innovate. Just make sure that best practices in data privacy and patient confidentiality are met. Um, the biggest one that is really making it difficult for others is the domain knowledge. That's why it would be nice to work together with hospitals, open hospitals or experts, because the domain knowledge can actually be overwhelming sometimes, especially if you want to go to deeper into hospital side operations. It's easy for the domain to just look at a single doctor having a practice just typing their notes. That's easy to digitalize, right? But if you look at the hospital operations, you're working with cancer patients, heart patients, outpatients, ER. That's a bit complex, but it's doable.
Okay, great. We have another question from Mark. How did you venture towards cloud computing? What are the technical difficulties and obstacles have you came across the journey? Did you have a hard time identifying what cloud services to use?
Okay. So when I started in this field several years ago, 20 years ago, everything was on premise, right? And even before the pandemic, I was a bit. Uh, I always recommended on premise because there are transactions that need to happen fast. right? Especially inside hospitals. However, after the pandemic, there was a need for quick digital transformation across almost all industries, right? And healthcare was just trying to catch up. So when everyone was already doing online buying, online selling, deliveries, everything is done online. Healthcare, you still need to go and pick up your own lab results. You need to go and uh, and get paper, right? So that's what we're trying to what we're trying to change right now. So um, what again? Did I answer the question?
Yes. We also have another question from Carlson.
Oh no, I remember the question was cloud. Okay, so sorry.
Yes.
When after the pandemic, we looked at cloud. So what's important with the situation right now is um, everyone was just waiting for data to be available outside patients, right? So the all healthcare institutions want to digitize. It became reasonable, logical to move to cloud because it would be hard to maintain your own data centers. So when it comes to our own software, we are open source advocates. So we don't require licenses. So any of the four uh, um, big cloud providers are actually okay.
Okay, thank you, Dr. Mike. We also have another question from Carlson. Could you give some strategies on how to address cross authentication for a project ecosystem with multiple microservices?
I think that is I would have to admit that I'm still studying on that one. Right now, all I know is the JWT method, but we're looking at one of the requirements that we have is actually the MFA. So we need to improve on that one. I'm sure at the back end that's still a JWT, but the front end needs to be part of the whole process, right? So um, I won't have a good answer for this one, but that's also something that we're trying to work on.
Okay, so moving on to Manuel's question. Since the software handles very sensitive data, do you also implement different IT security measures like data resilience, operational resilience, protection against cyber attacks, etc.?
Yes, yes. So one of the things that we immediately considered was actually a managed database, because a managed database in the cloud gives you automatic backups. So and it also gives you read-only nodes. So those two things are really helpful to help with the best practice. So you have some read-only nodes that would allow for querying or some reports, and then there's already automatic backup, and retention is 7 days, I think. So we don't have to worry about that. So if something happens, we have backups that we could actually go back to. Aside from that, because of the current our uh, situation with uh, government installation, we actually work with DICT and request for VAPT services. So we just finished one actually, I think 2 weeks ago, 2 weeks ago, or uh, no, a month ago, because we just um, work on the recommended fixes 2 weeks ago. There were no critical items, only low and medium ones that were identified. But because of that one, we plan to do frequent request for the VAPT.
Great. So, moving on to the next question from Marilyn. A key aspect of microservice security is protection against unauthorized access. What are your necessary security measure? What's the best challenge just to ensure it's implemented with strict compliance? I'm sorry.
Mm. Um, I mentioned earlier about the best practices for authentication. Um, That's what we're using. Um, we are open to just looking at where the weaknesses in our application lie, and then once it is shared and shared with us, then we try to address all of those. The recent VAPT work on, there's some updating of libraries and some configuration settings uh, along the DNS. But uh, when it comes to unauthorized access, if it's front end, then I mentioned the break the glass earlier. We make sure that that's for patient data. We make sure that the users actually are the users that are using it, and once um, they resign, they are automatically taken out of the system. Uh, I don't know, and then all the best practices at the back end side.
Thank you, Dr. Mike. And another one question from JC. How get upper management buy-in for refactoring into microservices as it usual to prioritize business requirements?
Okay, so the biggest buy-in, the biggest reason for buy-in was actually the ability to innovate and rapid deployment. So um, when you try to work, for example, earlier I showed the clinical uh, documents, right? We were trying to isolate the vital signs and probably the prescription. If this was a monolith and there were a lot of keys, foreign keys around with the e-prescription, it might take a while to disengage the vital signs and the e-prescription, okay, because it was a monolith. But because the patient database is already separate, it's already done API, we don't need to touch it. We don't need to touch a lot of the other ones. We just need to touch this microservice. And if we plan to do it, right now we're still working on other stuff, but if we plan to do it, it won't take a long time. So that this kind of concept allows the management to appreciate that, okay, this can be done well, this could be done, and there's also the ability to ramp up, okay, in terms of the labor cost. You just need to quickly fix something on one microservice. You could actually get a third party to work on this one, just on this microservice, bring it up, uh, put in the features that you need, and then give it back to the IT. So those are the advantages on the management side for getting the buy-in from top management.
Thank you, Dr. Mike. We have another question from JP. How do you effectively manage the scaling of multiple microservices repositories and their shared dependencies?
Okay, honestly, I have to check with my architect, my software architect, and especially uh, they try to do a lot of stuff in terms of managing the source code repositories. Um, that's something that I leave to my architect. I'm sorry, I cannot answer that one. But there's always an onboarding process for the new devs. They always share the different libraries. Uh, I think they're using Vagrant. So because we have a Laravel backend or Homestead, I think. Um, but I have to leave that to my software architect. I'm sorry.
It's okay, Dr. Mike. So another question from Maria Mara. How does microservices architecture differ from monolithic architecture in regards with the patient experience?
Oh, actually, it's better. Okay, so if we focus on the patient experience, we can actually focus on the patient portal. So um, we could try to isolate. It's easier to build a patient portal because you don't need to work with the monolithic database. So remember, if you just need to look at a patient portal that allows for maybe checking of my allergies, right? So you just need one or two microservices. You don't need to touch the others. If you want a patient portal that would allow for lab results, there's a separate microservice for that with a separate API. That within the context of the developers, you just need one more page and then that API feeds into that page. So that's easy. The next page might be e-prescriptions. Then you just build that another page. It's actually easier. It's better. And then the problem with the current monolith in healthcare is that it's everything is still installed. I showed earlier the screenshots. They're still installed in Windows and everything. So the web experience also matters with the new architecture.
Great. So for our last question from Zed, can data be shared across several microservices? If yes, what are some strategies to maintain data consistency to ensure the services are not working on stale data?
Agree, agree. There are things that we still need to consider. As much as possible, we try to avoid redundancy, but we cannot avoid that one. Right now, we are limiting it, so we have not yet encountered a big problem. But one of the areas that we will see this problem will be when we try to do a lot of reports. Because when we do some reports, we might need to stage some data, and then when you stage data, we might need to create redundant instances. So a patient data might be updated in the MPI, but within the stage data, it might be old. So that's also one of the things that we are looking at. That's why we are looking at the Kafka as a way to create event-driven or message-driven system. So that's one of the things that we are looking at. We are not yet there, but we understand that might be a problem. And then we're looking at the different technologies.
Okay, thank you, Dr. Mike, for answering all of our questions. To our audience, now, in case you guys still have questions, please feel free to chat with our speakers on our Ermit Lounge. And before letting you go, Sir Mike, can we ask for a quick photo op? Okay, that's all the time we have for this session. So again, let's thank our speaker, Dr. Michael Muin from Med Projects by clicking on the heart or clapping emojis.
Thank you,
Thank you,
everyone. Really
everyone.
appreciate it.
And to our audience, please exit this session and click onto the next. Bye, everyone.